try that again. So, all right. This is the behind the scenes of what happens when you're recording sometimes. This is what the Earth looks like in textbooks. On the outside, we have the crust, and then we have the mantle, the outer core, inner core, and it just gets hotter and hotter, which is why the colors usually go from like a browny crust, thin eggshell, to orange, then less orange, then more yellow, then towards white, because that usually is what heat does when it gets hotter. I mean, it doesn't go quite as hot as blue because that's hot, but anyway, I digress. But what would happen if we cooled the Earth down to the point where the rocks and metals within it solidified? You would get this. How cool is that? Now, this was made by an artist or a geological artist called Lena. She's phenomenal and has some amazing things on strike.dip.com. So if you want to see all of her work, make sure you go there. I had the pleasure of co-hosting a talk with her, a workshop last week, and I found this image and I just want to talk about it. Now, this is a simplified image, but it shows some really cool things. Naturally, right on the outside, not much changes because Earth's crust is, well, already cool enough to be a solid rock. So that's quite boring. Then we enter the upper mantle, where we have lots of pyroxenes and olivine crystals. Things like peridot. These normally cool with a green tinge, which is why we'll have an outer layer of this really cool green color. We'll then have wadsleyite, which is just above the blue ring, again a greenish tinge, before we enter the transition zone, which is ringwoodite, that infamous ocean of water under the surface that all of the tabloids basically said. That is blue in normal state, but it would eventually turn into a green color as it starts to cool down and turn into olivine due to it just lowering in a state. Then we have the lower mantle, which is perovskite. This is kind of boring. It looks like dirt. It's browny grey, but it will get more and more grey as it cools further, eventually resorting to like silicon glass, and it will have like this like basaltic appearance. After that, we get to the more interesting bit. So we have the more metallic cores with iron and nickel. Now, these are very shiny, but these have been polished clearly. But eventually, they'll just be these dull, just boring looking iron and nickel core centers. They basically won't really have much going for them. But we might see some outer oxidization at the transition zone between the outer core and the lower mantle, creating like a red rim. So yeah, that's what it kind of looks like versus what it could look like. Thanks for watching.